Good morning, everyone. So today we will start the other type of routing algorithm, that is a hierarchical routing algorithm. So previous class we have already discussed link state routing algorithm, and then there we have seen how the link state is formed, how the table is created, and then each router it will be having a linkage with the other routing, means the table contains all the routing information. So now we will study the hierarchical routing algorithm. So here, when you compare with link state routing algorithm, when you compare with link state routing algorithms, here we can able to see that in a link state, say if 10 routers are there, then each router will contain the information of rest all routers. How many hops are there, or else how many distance it covers, all information will be there with each and every router. Now here, when the network is going to become larger, then to keep a track of all the routing algorithm, that is the distance or else hops, it will become tedious for the router. So to avoid that, we can go for hierarchical routing. Now here, instead of each router containing all the information regarding rest all routers, that can be shortened, okay, by converting it into regions. Okay, so here routers will be classified into groups called as regions. First point, that is in hierarchical routing, the routers will be classified into groups, okay, known as regions. Now each router will contain the information about the other routers which is there in that region. Means if there are 3 routers like this, and these 3 routers fall in one region, if I call this as router A, router B, and router C, say if they are connected like this, okay. Now router A will contain only information regarding B and C, its neighbors. Now, say B is connected to some other router which is there in other region. Okay, means router A only contains the information regarding B and then C in its table, whereas B contains the information regarding A, C, and the other region. Means only B contains the data of other region, that to only one router. If it is connected here, say again like this, connections are there, and then here there are say 4 routers. So B will contain the information regarding A, regarding C, and regarding this router. Let us call this router as say E. So it will contain the information only regarding these routers. Okay, so that is what the second thing. This is what region 1, this is what region. Now routers just save one record in the table for every other region. Means this is what the router which it records regarding the other region. Okay, other routers will not contain the information of other region, like A and C will not contain the information regarding other region number 2. Routers only contain the record of their immediate neighbors in the table. So A's neighbor are B and C. C's neighbor are B and A. Similarly, the neighbors of B are A, C, and E, as per our example. Now, if still more the routers are increased in the network, means in network, if network is becoming larger, in that case, we can go for level 3 hierarchical routing. Okay. So if you are considering level 3 hierarchical routing, now there are regions. Just now I said this is region number 1, this is region number 2. Similarly, there can be region number 3, region number 4, region number 5. Now, if the number of routers are increasing in the network, then we can convert this to a level 3 hierarchical routing by considering a group of regions as one cluster. So this total group of regions, I will call it as cluster now. Okay. Similarly, there will be many clusters. In each clusters, there will be regions. In each region, there will be routers. Okay. In level 3 hierarchical routing, the network is classified into a number of clusters like this clusters. Each cluster is made up of number of regions, region number 1, 2, 3, 4 like this. And each region contains a number of routers. Okay. So region 1 contains 3 routers, whereas region 2 contains 4 routers like that. Okay. So in this method, it will route the first it will route first to the region, then to the IP prefix within the region. Means first it will go to that region, then it will search for the destination router. Means if I'm sending some data, that is A, if it is sending to say uh, to E. Now first it will go to B, then B to E, like this. Okay. So when it reaches here, it will check for the IP prefix. Then if it is not meant for E, it will forward here in its region. Okay. For example, if we consider there is one more router called as F, and here router we can call it as D like this. Okay. So if I want to send some information to D, it will go through B, E. Then when it comes to E, now it will think of D because it belongs to region number 2. Okay. So the information will be hidden to the routers which are outside the region. Means A, if it is sending to D, then D router is outside the region, so it is hidden. Information is not known to A. So these are the details which it is considered in the hierarchical routing. Now let us take an example and try to understand. Say we are having, I have taken level 2 here. There are 5 regions: region 1, region 2, region 3, 4, and 5. Region 1 contains the routers called as 1A, 1B, 1C. Similarly, region 2 contains 2A, 2B, 2C, 2D, 3A, 3B, 4A, 4B, 4C, 5A, 5B, 5C, 5D, and then 5E. Okay. As you already know that in previous class, we have already seen link state routing. If we are considering this in the hop pattern, means if I go from 1A to 1B, then it will be considered as one hop. If I'm going from 1A, 1B, and then it reaches 2A, then there are 2 hops, because first it will go here, one hop, then from here till here it will go. So there are 2 hops. Okay. Like this, each router will contain all the information if we are considering the other routing algorithms. Okay. Let us consider this table. Okay. Full table of 1A. Earlier routing algorithms table used to be like this. Okay. Now we will compare with our hierarchical table. Okay. So full table 1A means this table with 1A router. There will be table like this with 1A. So what all information it contains? If it is other algorithms, it contains all the information regarding rest all routers. Okay, that is what called as full table. Okay, so 1A to 1A, it will not go. So it will be dash. If I'm going from 1A to 1B, it will take one hop. It will take one hop. Okay, that's why you can able to see 1A. If I'm going to 1B, it has taken one hop. Similarly, if I'm going from 1A to 1C, it will take again one hop. And the line chosen is direct. Line chosen, it is direct like this line only, 1A to 1B. Similarly, 1A to 1C, direct connection it is there. I'm not going through. Okay. Now, 1A to 2A, if I want to go from 1A, if I want to go to 2A, from here, from 1A, if I want to reach 2A, 1A to 2A, how I can go? I can go first to 1B, then to 2A. This is what the shortest one. Else what I have to do? I have to go first 1C, then 1B, then 2A. Means if I'm choosing this path, that is 1A to 1C, then to B, then here, I'll be taking 3 hops. Okay. Rather, if I take this path, that is from 1A to 1B, then to 2A, I'll be taking only 2 hops. So smallest is 2 hops. That's why we'll be choosing this part. Okay. So from 1A to 2A, if I want to reach destination, then I have to make use of 1B line. 1B line, I will be taking 2 hops. I'll be taking 2 hops, 1 hop, 2 hop. Okay. Similarly, if I want to reach 2B, automatically I have to choose this path itself, 1A to 1B, then to 2A, then to 2B, from here to here. Okay. Means the line chosen is 1B only. Here, 1A to 2B, I want to reach. So line chosen is 1B itself, because that is the only direct connectivity to reach 2B. It has taken 3 hops. Similarly, if we go on calculating, if I want to reach 2C, then again it will take 3 hops, because it has to go from 1A to 1B, then to 2A, then to 2C. Okay, so 3 hops. 2C, it is 3 hops. Line is 1B itself. 2D, I have to go either like this, that is 1B, then 2A, 2B, 2D. This is one way. Or else 1A, 1B, 2A, 2C, then to 2D. In both the cases, it will be taking 4 hops itself. 1, 2, 3, 4. So automatically it will take 4 hops itself. But how I have to go? That is, I have to choose 1B line itself. Similarly, to reach 3A, I have to make use of 1C. Because if I'm making use of 1B, I will reach region 2. I will not go region 3. So I have to make use of 1C. Okay. So 1C, directly I'll be reaching 3B, then to 3A. Okay. So if I want to reach 3A, I will be using how many hops? 1, then 2, then 3. That's why 3A, it is 3 hops. Similarly, 3B, it will be 2 hops. Then 4A, if I want to reach, I have to make use of 1C itself. I have to make use of this line itself. Okay. Then 4A. So 1 hop, 2 hop, then 3 hops. Okay, 3 hops. Similarly, 4b, it will take 4 hops. 4c, it will take 4 hops. If I want to reach 5a through 1c, through this 1c, then it will take 1 hop, 2, 3, 4 hops. Okay. Similarly, to reach 5b, I will take 5 hops. 5c, I will take 5 hops. Then here 5c, 5c, I'll take how many hops? 5 hops. Through 5b, 5 come. If I go like this, then it will be taking 6 hops. See here, I want to reach 5c, 5c. So either I can go like this, 1, 2, 3, 4, 5, and 6. So here, if I am taking this path, then it will take 6 hops. Okay. If I go like this, 1, then 2, 3, 4, and 5. So if I go like this, it will take 5 hops. That's why to reach 5c, the best path is 1b. Okay. Now to reach 5d, 5d, okay, it will be using 1c, because here it takes how many distance? 6 distance. So here also it will take 6 distance, either of one. Okay, so 1c. Similarly, to reach 5e, the best path is through 1c itself. From here, 1c itself. Like this, if I am coming, then it will take 5 hops. So this is how the table was created in earlier algorithms, not in hierarchical. Okay, in earlier algorithms, we have seen so many algorithms there also. We have seen a link state algorithm. Okay, previous to that, other algorithms also we have seen. So like this, the table used to be created. But here, each router will contain all the information. Now, if the number of routers are getting increased, then the length of this table also goes on increasing. Suppose if 100 routers are there in the network, then it should contain all the 100 links, all the 100 lines. All this information should be present with the router, okay, which becomes very difficult to maintain. That's why we will go for hierarchical table. So in hierarchical table, what is done is, now we will just compare. This is what earlier routing. You can consider it as link state routing. Okay. Now here in earlier routing, this was the table which the 1A contains. Now when we are using hierarchical table, already we have told the rules and regulations. The points need to be considered in hierarchical routing. That is what each router will only contains the information regarding the neighboring router. Means when we are talking regarding 1A, it just contains the information regarding 1B and 1C. Already we know that 1A to 1A, no line is required, no hops are required, because it is the same router. Okay. To reach 1B, it will take 1. To reach 1C, it will take 1. Okay. Now, to reach any router in the region 2, to reach any router in region 2, it has to make use of 1B, has to make use of 1B, because that is the only link we are going to get, which will give you the shorter hops. Shorter hops. Number of hops will be less. Okay. If I consider this 1A to 1B, then to 2A. Okay. That's why to From 1A, if I want to reach region 2, the best line, best way best route is to go through this 1B. That is, we will be taking only 2 hops. Later on, when it reaches here, automatically these routers, that is router 2A, will decide the IP prefix and will send it to the destination which is present in region 2, because 2A contains the information regarding 2B, 2C, and then 2D. Okay. Similarly, if I want to reach region 3, the shortest distance is through 1C. So 1C, I will be taking 2 hops because 1 and then 2. Later on, this will forward to 3A. Suppose from 1A to 3A, if I want to send, table just contains 1A to 3. I have to go through 1C and then hops are 2. 1 and then 2. Now region 3 will search for the destination and then forwards. Okay. So this is how it contains. Next, to reach region 4, it has to go through this 1C itself, because 1, 2, 3 hops. It will take 3 hops to reach region 4. Similarly, to reach region 5, 1 hop, 2 hops, 3, 4 hops are required. Okay, 4 hops are required. Now here, if I am going like this, 1 hop, 2 hop, 3 hops, 4 hops, and 5 hops. That's why it will take which one? If I am going like this, I can reach 5 in this way, or else I can reach 5 in the other way. Now, if we are checking the number, the number of hops to reach region 5, the best is to go through 1C, because here it takes 1, 2, 3, 4, and then 5. Here it has taken 5. Okay, to reach region 5. Okay, to reach region 5. Similarly, to reach region 5 through 1C, it has taken 1, 2, 3, 4. 1 hop, 2 hops, 3, 4 hops. So it has taken 4 hops. That's why 5, it is showing 1C. But one problem it is going to arise here in hierarchical routing. For few of the cases, like 5C. Okay, suppose I want to send, that is 1A wants to send some information to 5C. From here, if I want to send some information to 5C, now the shortest path actually is through 1B. But as a hierarchical table, it contains 1C. So it sends like this: 1, 2, 3, 4, 5, and 6. It takes actually 6 hops to reach 5C. Okay, but this we can consider it as minimal comparing to the reduction of the table. Okay, so only each router should contain only this much of the table information, need not contain the complete information. So this is what all regarding the hierarchical routing, and then the use of hierarchical routing, and then how the table is reduced by using this routing algorithm. So this is what the advantage of hierarchical routing. Hope so you have understood. So today we'll stop. Thank you.